something I like to think about sometimes. Say you want to try to list just all the real numbers between 0 and 1.
Sometimes the simplest questions have the most amazing
many,
answers.
And you can't even
Like,
make a
how
scheme
can
for listing
trees
them
be
because
so
you just
tall?
can't.
It's a question that doesn't even seem like it needs an
Just
answer.
something
Trees
a little
just
bit
are
impossible
tall.
doesn't
Some of them
mean they
are
can't
over
anyway.
100 meters.
So,
Why should there be a height limit? I'll tell you why. Trees need to transport water from their roots up into their topmost branches in order to survive. And that is no trivial task. There is a limit to the height that water can be sucked up a tube. It's 10 meters. If you suck on a long vertical straw, the water will go no higher than 10 meters. At this point, there will be a perfect vacuum at the top of the straw, and the water will start to boil spontaneously. For a tree to raise water 100 meters, it would have to create a pressure difference of 10 atmospheres. How would trees do that? When I posed this conundrum, a lot of people said the answer is transpiration. And that's when water evaporates from the leaf, pulling up the water molecules behind it. And that's clearly a mechanism a tree can use to create suction, but it doesn't help us overcome this 10-meter limit.
The lowest the pressure can go is your vacuum, which I imagine is not happening inside a field.
Right, Hank. So you might suspect that a tree does not contain continuous straw-like tubes.
And they floated out in
And I guess 0 is
So
more
you
than
have
1.
to
That's fine too. And
This big tube, what you're saying is it's actually made up of cells.
Although these are good speculations, they don't turn out to be correct. Scientists who study trees find that the xylem tubes that transport water do contain a continuous water column. So how else could the tree transport water from the roots to the leaves?
They don't suck, they don't use a vacuum.
Okay, so how do they do it?
Squeezing like a cow, like you see a cow under all the way up to the little tree muscles in there. Yeah?
Besides being a giant waste of energy, all of the cells that make up the xylem tubes are dead. What about osmotic pressure? If there is more solute in the roots than in the surrounding soil, water would be pushed up the tree. But some trees live in mangroves where the water is so salty that osmotic pressure actually acts in the other direction. So the tree needs additional pressure to suck water into the tree. Then it must be capillary action. The thinner the tube, the higher the water can climb. But the tubes in a tree are too wide. At 20 to 200 micrometers in diameter, water should rise less than a meter. So how do trees do it? Well, one of the assumptions we made is wrong.
The lowest the pressure can go is your
That
vacuum.
if the number of nodes
In a gas, this is true. When you eliminate all of the gas molecules, the pressure is 0, and you have a perfect vacuum. But in a liquid, you can go lower than 0 pressure and actually get negative pressures. In a solid, we would think of this as tension.
finite case thing doesn't mean it's true.
We've done several videos.
Sure, if your number has a finite number of digits, it has a path along those digits.
They create immense negative pressures of minus 15 atmospheres in an average tree. Think about the air-water interface at the pore. There is 1 atmosphere of pressure pushing in and negative 15 atmospheres of suction on the other side. So why doesn't the meniscus break? Because the pores are tiny, only 2 to 5 nanometers in diameter. At this scale, water's high surface tension ensures the air-water boundary can withstand huge pressures without caving. As you move down the tree, the pressure increases up to atmosphere of the roots. So you can have a large pressure difference between the top and the bottom of the tree because the pressure at the top is so hang on. The pressure at the top is so instantly the thermite boundary starts. You can see that it's so that terracotta flower pot. If we're going close over, ready? You can see all that really quite nice mold. Tiny air bubbles. That's why it's so important. The xylem tubes contain no air bubbles, and they can do this because unlike a straw, they put water in the water remains just like water remains liquid even though it may be ice. You can say that water in a tree is sucked because it remains liquid at wow negative pressure. What a fantastic reaction. Why are trees of the water is used to make these cells. So what happens to the other 95% of the water? For each molecule of carbon dioxide that tree takes in, it loses hundreds of molecules of water. Can you believe how amazing this is? Trees create huge negative pressures of tens of atmospheres by evaporating water through pores, sucking water up in a state
Yeah,
where it
and
should
trade.
be boiling but can't because the perfect xylem tubes contain no air bubbles, just so that most of it can evaporate in the process of absorbing a couple molecules of carbon dioxide. I will never look at trees the same way again.